Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you, all the students at any point of time wherever you are listening and hearing this set of lectures. The title of the course, as you all know, is Multi-Criteria Decision Making, and this is under the NPTEL MOOC series. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur in India. And as you can remember, the main portions which we were discussing for quite a set of weeks was basically about non-parametric multi-criteria decision making. I will repeat few of the things which you have already done in details: Electra method, epsilon Electra, Topses, Y core, and then we are in AHP method. We have discussed some of the AHP methods, and here in the class, which is the last lecture of the 11th week, we will consider the remaining portions of AHP. Few of the slides would be repetition with respect to the 54th, plus please bear with me. The main course name or the subtopics or topics, whatever you say, is multi-criteria decision making. We have covered a whole lot of multi-objective decision making, utility theory, some concepts of multi-attribute decision making which you are doing, multi-attribute utility theory also, just the basics, and we are in the 55th class out of the 60 lecture series or class series. The coverage is the continuation of analytical hierarchy process AHP, and I have drawn some diagrams in details to explain that in the 54th class. Now, if you remember, we were discussing about buying a car, and all the three examples we have been discussing about brands of cars or the different type of colleges one would like to select, and the third one problem was about buying an apartment. We will stick to the buying a car from a set of brands. And if you remember, for buying a car there are many different criteria to be analyzed. Few of them I will repeat. These one is the horsepower of the engine, the safety features, the looks of the car, the cost of the car, the maintenance cost also, resale value, then the luggage space, number of passengers which you can sit, and based on that we are considering a very simple set of criteria, and I will mark them accordingly here. The first one is style. We had discussed, but I will just briefly again rerun those important concepts: cost and fuel economy, and these are all criteria for the first level. First level means the hierarchy we are considering. Also along the row we have style, cost and economy, and as I mentioned, the principal diagonal which I am marking in red color is all one, because we are considering style to style, cost to cost, fuel economy to economy, fuel economy. And the of the diagonal element which I will now mark in green, which I do that in order to highlight the different concepts using different colors. So, cost to style, cost is twice, and obviously the reciprocal would be for style. So, cost is more important. For the same person decision maker, if I consider cost to fuel economy, the ratio is basically 4:1/4. So, again I am marking in green, and the last one, if I consider fuel economy to style, the ratio is 1/3 to 3. So, these values of 3:1/3, 2:1/2, 4:1/4 all depend on the decision maker. So, obviously, if I am taking the decision to buy a car, my set of points may be different from you all. Or say for example, in the same family, if two people are deciding to give some weightages about all these qualities of buying a car, like say for example, husband and wife both have a say in trying to buying the car, they may have different notions of how the scores are given. Now, remember one thing which I will draw in order to. So, your main decision which I will mark in a dark red box is basically the decision, and under that you have the different criteria, sub criteria and hierarchy. So, I will mark the first level in green color. So, consider this is 1, this is 2, this is 3. Then the next one I will mark in blue in order to differentiate. For the first one there are 2, second one there is 1 and third one again there are 2, and these first hierarchy and the second hierarchy are interconnected. So, I will draw them. Here is the list of the first connection for the first hierarchy, second hierarchy, and finally, there is the alternatives. Alternatives, if you know, I will mark in violet. Consider there are 3. Consider for this example. So, they are connected from the second level accordingly. So, again this point is connected and finally, the third. So, I will mark the alternatives. This is a repetition, plus please bear with me. This is A1 alternative 1, A2 alternative 2, A3 alternative 3, and if you remember, the criteria are marked by C1, C2, C3, and if I consider the next level, I will mark in blue color. They are correspondingly C11, the second one is C12, third one is C21. So, obviously, there is no C22, but still I will mark it C21. The next one under C3 is C31, the last one is C32. So, when I am considering, why did I draw all these things? When I am considering the comparison of the first hierarchy, which is basically style, cost and fuel economy, I am comparing the criteria which are shown in green, and obviously, I can continue doing so for the second hierarchy and continue accordingly. Then I will consider the alternatives with best with the criteria also. So, this snapshot or of this slide number 4, which shows only one level of comparison. This can be replicated for different levels of comparison for the hierarchy and also considering the alternatives with the criteria. Now, here what we have considered in the last class, I will just repeat. So, consider A is the comparison matrix at each stage. Each stage means considering the criteria, sub criteria, or considering the alternatives with the criteria, and if we continue different combinations. So, A is the comparison matrix of size n cross n. Now, here n in the last diagram, as you saw, was 3 by 3, because there were 3 criteria along the row which you are considering and on the column. So, obviously, when we come to the portion which is marked in blue, dark blue, not the violet one. So, obviously, it will be size 5 5 5. So, n basically denotes the size of the matrix and it will always be a square matrix. Similarly, when we consider the alternatives and proceed accordingly. So, A is the comparison matrix of size n cross n of n criteria, also called the priority matrix. Here I am considering the criteria, obviously, they can be sub criteria also. X is the eigenvalues of size n cross 1 for that n cross n matrix, and lambda max is the eigenvalue. So, eigenvalues and eigenvectors are found out in order to find out the level of importance and how the criteria or the sub criteria can be broken up in order to understand their level of significance. Because for person 1, which is the decision maker 1, maybe fuel cost is very important for me. For decision maker 2, on trying to buy the same set of alternatives or the cars which are there in front of him or her, and the same level of criteria which are there, for him or her maybe purchase price is important. So, based on that, depending on the scores which have been given at each level, criteria, sub criteria, the eigenvalues and eigenvectors will give you the level of importance, how is being differentiated. So, here x is, I am just putting the highlighter, is the eigenvalue vector and lambda max is the eigenvalue. Now, to find the ranking of the priorities, namely based the concept of ranking which I mean is depending on the score which was given, we will use the eigenvector x, and we need to basically normalize the entries by dividing each by the sum of the columns. So, if you remember the concept, of trying to normalize along the column. The word column was mentioned time and again. We had considered in Electra method, we had considered in epsilon Electra method, we had considered in Tops's method, we had considered in Vicor method also. Even though I did discuss in details about the concept, but few of the ideas were repetitive in all these 4 methods which I just mentioned. So, in many of these methods I may have just mentioned it, considering that those ideas were already considered in the previous set of lectures. Normalize the column entries by dividing each set by the sum of column and you take the overall row average. So, what we do is that if you see the n cross n, which is 3 cross 3 for the first level of criteria, which is the first hierarchy, the values along the principal diagonal were always 1 as they should be, and the off the diagonal elements were 2 is to 1/2, then 1/3 is to 3, 4 by 1 by 4, and this basically we analyze and normalize along the columns. So, once we do that, the normalized values are this, which are, if I am reading along the column, first column 0.3, 0.6, 0.1. So, that adds to 1. The next value is 0.28, 0.57, 0.15, and the last value is 0.37, 0.51, 0.12. So, if I consider 7 plus 1 8, 8, 9, 10, 3 1 4, 4 plus 5 is 9, 9 plus 1 is 10. And similarly, if I do 8 plus 5 is 15, 15 plus 5 is 20, then 2 plus 2 4, 4 1 plus 5, 5 plus 5 1. So, I am double checking that they are 1. Now, what does that mean? That actually means the level of importance when I am considering for the set of criteria is when I only concentrate on criteria 1, which is basically along the first column. Then the level of importance which the person will be placing is 30%, 60%, 10%. That means, all his concentration or her concentration is only on criteria 1. Similarly, when I consider the level of importance for criteria 2, it is 28, I am not reading the decimals, it is 28, 57, 15, and for the third criteria, if I read the third column, is 37, 51, 12, again I am not reading the decimal. Now, what are these comparisons? These comparisons is concentrating only on criteria 1 or only on criteria 2 and only on criteria 3, criterion 3 which you have, you are trying to find out that if your concentration was only on C1, which is criterion 1, then how it would basically be analyzed considering C1, C2, C3, which are along the rows. Similarly, when I consider column 2, it is paying attention to C2, the second criteria, and then how the overall analysis would be done based on C1, C2, C3, again along the rows, and finally, for the third column accordingly. So, what we need to find out is the priority vector, which I just find on the average. So, the average one along the rows would be add up the values and then divide by the number of such values which you have. So, it is 3. Now, once you have that, the criteria weights are given and the criteria weights are as marked, and I will mark it with red color. So, style, cost and fuel economy. What it actually means is that trying to find out the weights accordingly, we would give, or the decision maker would give, about 30% weightage to the style, 56% weightage to the cost and 12% weightage to the fuel economy. Now, if you remember, in this matrix which I have just circled in red, they were individually for each criteria, and considering the comparison was being done for C1, C2, C3, which was along the rows. Now, we have found out the averages, that means, on the long run what would be the overall importance the decision maker would like to place on C1, C2, C3. This is the set of values, or these are the set of values which we have obtained. Again I am repeating 32, 56, 12, I read them without the decimal. So, if I basically add up, is 6 plus 2 8, 8 plus 2 is 10, then 3 plus 1 4, 4 plus 5 is 9, 9 plus 1 is 10. So, the addition basically adds up to 1 as it should be. Now, what it means, if I look at that level of hierarchy, then selecting a new car which should add up to 1 would basically be in the level of importance the decision maker would place if the total score is 100, or the total level of importance is 100, or the total amount of weightage is 1, the person will be putting a weightage of 32% for style, which I just mentioned, 56% on cost, and fuel economy being 12%. Now, this is decision maker 1, it can change depending on the decision maker. That is point 1. Point number 2 is this type of hierarchy can be made for the second level of hierarchy, and we can continue and basically draw the overall diagram accordingly. Now, what is the diagram which I have drawn and I still highlight, which we have done in the last class, we have already done in this class also, which I will again highlight here and go back to the last slide. So, the hierarchy which we want to find out, and I will basically highlight it with the light green, is this is the hierarchy. So, the points which you see here along the black so called lines, which are, or the arrows which is joining hierarchy 1 to hierarchy 2, which is the last one to the alternatives, are the points which you are trying to find out, which we found out for the level of style, cost, economy, which was accordingly found out. What were those values? I will again repeat it. The values were 32, 56, 12. Now, if I pay attention to the one of the diagram which we have done, or the diagram which we considered the Ram and Shyam making a decision to choose which IIM to join, A, B, C, and they had level of importance on placement potential and the academic rigor. So, the diagram was like this: first level, which is the decision you want to take. Consider next we have hierarchy 1, and then we have, say for example, hierarchy 2, and consider there are only 2 alternatives in order to make our life simple. So, if I want to basically draw it, here again I will mark the alternatives. As I said, there is only 2, A1, A2, and these are the criteria which I will again mark for completeness of the diagram. So, this is C1, C2, C3, and the next level which was shown in blue was C11, C12, C21, C31, and the points which are being mentioned are along the black arrows. So, they would basically be multiplied accordingly. So, if I have, I will mark them in black color. So, see for example, if this is A, from going from capital A1 to C11, this is small b going from C11 to C1, and this is small c going from capital C1 to the decision. So, decision is basically I will mark as decision, which you are going to. So, if I consider A, B, C, and then I have, see for example, D, E, then we have F, G, H, I, J, K. So, if I am basically trying to find out the overall score for A1 to reach the decision, what are the points? Points would be from capital A1 to capital C11, it will be A, and the corresponding points which will be there would be A into B into C, the first route. Then the next route would be plus D, AEC, which is from capital A1 to capital C12, then capital C1 till the decision. The next route would be plus FGH, which is capital A1 to capital C21 to C2 and the final decision. And finally, the last one would be I into j into k, which is from capital A1 to C31 to C3 to the decision. So, likewise we will basically find out all the routes, sum them up, considering alternative 1 till the decision, alternative 2 till the decision, and if there are, say for example, m number of decisions, we will basically find out such values, multiply along the route, add them up for all the routes and basically rank them from the maximum to the minimum. Now, one thing you should remember, which would be very intuitive, because if you remember when we are finding out average. So, let me go back to the average here. When we were considering the averages, we were considering technically, if you remember for epsilon, Electra method, Topsis method, Vicor method, we always consider there was a weights based on the criteria. Here we are considering the weights are being equal, that is why we are basically putting 1/3, 1/3, 1/3 weight. So, that weights can be changed according to the level of importance somebody wants to put on the criteria. Here we are considering 1/3 equal weightage. Now, once we have done for each and every set of criteria, sub criteria, we need to find out what is the consistency ratio. The consistency ratio would be, for non-parametric methods, consistency ratios are important, and I will mention why, which I think I have discussed, but I will just mention it once again. Considering that in the multi-objective case, if you have the real line and you want to basically mark the level of the numbers. So, say for example, if I say the property of 3 being, if I consider the numbers on the right hand side that is increasing, 3 is better than 2 or greater than 2 and 2 is basically greater than or better than 1, then obviously 3 is better than 1 as per the numbering scale. But here if I have the alternatives, it may happen this one, A1 is better than A2, A2 is better than A3, but there may be cases where rather than having A1 better than A3, you may get a different answer, which I am marking in red, is that A3 comes out to be better than A1. So, in order to basically check for consistency inconsistency, which would arise like this, we need to basically check with the consistency ratio, and that consistency ratio for the AHP would be given. So, the next stage is to calculate the consistency ratio to measure how consistent the judgments are relative to the large number samples of purely random judgments. Now, why this problem occurs? Because if you remember in all the methods, I will keep repeating the methods, please bear with me, for epsilon, Electra method, Topsis, Vicor and this AHP method also, when we are comparing the alternatives among themselves based on the criteria, or when we are considering the criteria also in the example which we saw, the decision to compare is only 1:1. That means, taking 2 criteria or only 2 alternatives one at a time at each go, and in such a way that we ignore the influence of the rest, which practically is not true, theoretically is true here in this problem. Now, what problem does it create? That means, if the number of criteria, the number of alternatives is huge, then trying to basically measure perceptible logical judgment may not be right always, because in that case you are only considering 1:1 and in that process ignoring the rest of the levels of influences. So, in order to overcome that, that is why the consistency ratio and calculating it and comparing is important. AHP evaluations are based on the assumption that the decision maker is rational. As I said, if A is preferred to B and B is preferred to C, then A is always preferred to C, which may not be true in many of the decisions. If the CR is greater than, which is consistency ratio is greater than 0.1, the judgments are untrustworthy because they are too close for comfort to randomness, and the exercise is valueless or must be repeated, and the questions may be asked by the decision maker, or the decision maker should analyze repeatedly. So, the next stage is to calculate the lambda max so as to lead to the consistency ratio, and the lambda max is basically given by the formula. So, we have already found out A was the level of scoring which you had given for any comparison of the criteria or the alternatives, and x is basically the eigenvectors which you have found out, and based on that I find out the lambda max. So, we know the formula which I will just highlight, A x is equal to lambda into x. This is the known, very important known equation in basic mathematics, where again I am repeating A is the matrix of the scores given, and the scores given, if you remember, the principal diagonal is 1, of the diagonal are not symmetric. Lambda max is basically the eigen vectors and eigen values, and x is the eigen vectors. Based on that, we find out the value of the lambda max. So, what we do is that A x into lambda max is equal to x. So, these values of A into x are already found out based on the average values of x we have found out along the rows, and based on that lambda max is found out as the average. So, the averages are given. So, you have the averages values which are already there, 0.32, 0.56 and 0.12. Based on that I find out the lambda max, which comes out to be 3.04, and based on the formula given by Sate, we find out the criticality index Ci, and here n, remember, is basically the size of the matrix based on which we are working. The value is basically comes out to be 0.02, and these values which are calculated, lambda max, are given here. So, the scoring system for the criticality index or ratios is given. The random index values for n 0, 1, 2, 3, 4, n is basically the size of the matrix. The values of random index are given. Critical index has already been found out, which is 0.02, n is 3, size of the matrix was 3. Based on the table, we have, so 3 and 0.52, so we are considering 0.50. The value of the ratio would be basically Ci by Ri, and if you remember, the criticality index was 0.02 calculated, and the value of the Ri is basically 0.52, which comes out to be 0.04. So, as it is less than 0.01, which indicates sufficient consistency is there for the decision. So, you have to basically find out for each and every step. So, I will try to finish this AHP part in this 55th lecture. So, I may take a little bit extra. So, once you have that, now I will repeat the same set of calculations for all the comparisons. So, if you remember, I mentioned that, and here it is. What were the alternatives? Alternatives or the brands of the car was Civic, I-20, Escort and Alto. So, I compare the alternatives based on the first set of criterion, which is style. So, criteria is style, I compare them. How do I compare? Again the same methodology. The principal diagonal, which I will mark in light green, is 1, and the comparison which is happening, for one example, let us consider Alto to Civic. So, I placed a score of 6, which I marked in blue for Alto with Civic, and obviously the corresponding level of points which I will place on Civic with respect to Alto is 1/6. Now, this 6 and 1/6 is placed by the decision maker. So, it may differ from decision maker to decision maker. Similarly, when the person, the same decision maker, is comparing Alto with Escorts, he or she puts a score of, say for example, 5:1/5, or that person is comparing Alto with, say for example, I-20, the person is putting a weight of, I will use another color, violet one, 4:1/4. So, look, all the values are reciprocal with each other with respect to the principal diagonal. So, he or she does for the style and the priority vectors which have been found out in the same way, like finding out the average, first normalizing them along the columns, finding out the sum is 1, then finding out the average, finding out lambda max, repeating the same set of steps of criticality index, criticality ratios and so on and so forth. For that, the priority vector for style when being compared for all the 4 alternatives is given here. Similarly, when the same decision maker tries to find out for the cost, that criteria for all the 4 alternatives, again the principal diagonal is 1 of the diagonal are asymmetric, the priority vector comes out to be this. So, this priority vector, if you want to compare this value, we have done it for the case of selecting the car, the priority vectors or the weights were coming out to be 32, 56, 12. I am again saying them values without the decimal. Now, here if I go back, it means the level of priority or the level of importance based on style only for the 4 cars is 13% for Civic, I-20 24%, Escort 0.07 and Alto 56. When I go to the cost factor, one of this the important factors based on which the choice for the 4 cars is made, then the priority vectors have changed. They are, I am again repeating without going to the decimals, 38, 29, 7, 26. So, obviously, we will see the priority vectors based on the set of important points which is style and cost would differ, because the person decision maker has different level of importance for this style and cost. Now, coming to an additional one which point which may be quantitative. Here consider the kilometers per liter and the priority vectors are found out. Kilometers per liter basically means arbitrarily I consider 34, 27, 24 and 28 is basically kilometers per liters for all these 4 alternatives, and the priority vectors based on them are found out. Priority means the same level of importance which I put comes out to be, again I am reading with the decimal now 0.30, 0.24, 0.21, 0.25 add up to 1. Since fuel economy is a quantitative measure, fuel consumption ratios can be used to determine the relative ranking of the alternatives. So, obviously, in this case higher the ranking, priority vector means more the level of importance you will try to place. So, we will consider both the quantitative one as well as the qualitative one and then combine them, have the final decision tree such that at multiplying for along that any path and then adding up all the different paths leading from one alternative to the decision maker, we will basically prioritize them accordingly. So, here selecting the cars, the levels of importance are for style we have this, for cost we have this, fuel economy we have this. Fuel economy was quantitative and style, cost, fuel economy on an individual scale if I compare was 0.32, 0.56, 0.12 and in between for all the 4 alternatives for style, again I repeat 13, 24, 0.07, 56, similarly for cost and similarly for fuel economy. Once I have that ranking, I basically find out, and now the matrix which I have is the alternatives along the rows and the criteria along the columns. Now, this is what is the final decision we are going to make. So, this is the priority matrix, the criteria weights are already been found out for the criteria which was for the 3 levels 32, 56, 12 and based on that we basically have the overall score as given as 28, 25, 0.07 and 34. So, adding cost as a new criteria is very difficult in AHP. A new column has to be added, new row has to be added in the evaluation matrix and each and every stage depending on the addition. However, the whole evaluation should be repeated since addition of a new criteria might affect the relative importance of other criteria as well. So, instead one may think of normalizing the costs directly and calculate the cost benefit analysis. So, consider the cost effect, note from the fuel one, the cost effects are given and the normalized costs are given. So, consider the benefits, benefits are on a scale of 100. So, what the person wants to find out is basically the cost and benefit. Obviously, this is in the reverse order, cost being in the numerator, benefits being in the denominator. So, obviously, it will go in the reverse order and found out accordingly. So, the highest one would be the lowest ranked and based on that you calculate. So, these are values which are taken from the data and they have been normalized accordingly. So, in the overall scheme, the escort would be the winner with the highest benefit or cost to ratio. So, that means in the reverse order, second being that of I-20, third being Alto, while the fourth position will go to Civic. So, what are the advantages of AHP? Is multi-criteria, is a multi criteria decision making, where you can consider both quantitative and qualitative evaluation. It is applicable to for group decision making environment also. The hidden assumptions are about consistency. So, in many of the cases, repeating the evaluation may be cumbersome, same thing is being done, and when the number of criteria or alternatives is more than 7 or some number, it may be difficult to compare, because in that case inconsistency may crop up, as I told you. It is difficult to take out an existing criteria or alternatives, and basically because the effect of the criteria and alternative would also already be subsumed in the overall set of calculations which are being done. So, for consistency, just on a very simple scale, for a matrix to be consistent, the first criteria is when I consider along the rows and the columns, which is Aij into Ajk should always result in Aik. These are just points, nothing to go into the derivation. A 2 by 2 matrix is always consistent, and consistency would imply that all rows and columns are linearly independent. So, this is just a simple case of a matrix is consistent. If I have n, which is n cross n matrix, where the not the weights, the values are given by W1, and then I basically find out the matrix A, and what is A is here. So, basically Wi's are calculated based on the criteria, and they can be considered as consistent. So, hence A multiplied by the matrix W would be consistent if and only if the sum of the average weights, which is W bar, is basically equal to all the average values corresponding to the values along the rows which I have. So, I went a little bit fast in the later portion of the AHP, because rather than continuing in the next week, it is best that if you spend a little bit more extra time and cover the AHP, it would be better. Thank you very much for your patience, and in the next last week we will start with the remaining portion of the course. Thank you very much for your attention, and thank you for your patience.